Right. So next question is asking us what is the sketch of the graph of fx is equal to e to the exponent of x plus 1. Let's move it here. Right. Yeah. So first, let's say the step 1. We need to understand the transformation of it, which means, let's say we have a gx, which is equal to e to the exponent of x, and after a certain transformation, we will get our fx, which is equal to ex plus 1. So first, let's draw a sketch for ex. So we have something like this. So that's gx is equal to ex, yep, where it intersects y-axis at 0, 1, the coordinate is 0, 1, and it will infinitely get close to x-axis, but never cross it. Oops, x, y, and this is 0, 0. All right. And so that's the sketch for gx, and some characteristic for gx. I'll write it on here. So it's upward sloping and always lies about x-axis. Right. So always lies about axis means its y value is always going to be positive. Right. And the second characteristic is for positive values of x, the graph increases faster and infinitely. Increase faster and infinitely. Yep. So this goes to infinity. And the third thing is, like I mentioned about, it intersects a y-axis at 0, 1. And I forget for the negative value of x. For negative values of x, where is this part? the graph approaches but never touches x-axis, and where x-axis is its horizontal asymptote. So that's the next point. Horizontal asymptote is x-axis. Yep. Right. Right. So by knowing this, we can do our transformation. So so as you can see, from e to the exponent of x to e to the exponent of x and then plus 1 for the y value, which means we just shift the whole graph 1 unit upward. So let's write it on here. Shift the graph 1 unit upward. Right. So let's copy down the graph we have about. Right. So this should be, because we're moving 1 unit upward, so the original y-intersect point 0, 1 should becomes to 0, 2. So let's use blue. So from 0, 1 to 0, 2, and so it should be something look like this. So that's fx is equal to e to the exponent plus 1. Right. And yeah. And let's talk about the characteristics for fx. So characteristic for fx is equal to ex plus 1. It is quite similar to the characteristic for gx, but there are some minor change. Okay, so the first one, it is still upward sloping. Upward slopes. And still always lies above axis. And then for positive values of x. Yep. So we're talking about this part for now. It increases slower than y is equal to ex, but still goes to infinity. Right, so still goes to infinity. And next thing is for negative value of y, which is the green part. It approaches but never touch the line y is equal to 1. And remember, for gx, we never touch the x-axis, which can also be written as y is equal to 0. And now, since we move the whole graph 1 unit upward, so now it will approach us but never touch the line y is equal to 1. Yep. And now y is equal to 1 is our horizontal asymptote. Right. And as we mentioned earlier, it's shaped upwards 1 unit, so the new y-intersection point should be in 0, 2. In 0, 2. It intersects the y-axis at 0, 2. Right. So yeah, so those are the characteristics for fx. And then now we can write our conclusion. Therefore, the graph of y is equal to ex is shown above. It is upward sloping, increase slower than y is equal to ex, but still infinitely for positive values, of x, in the graph approaches but not touches the line y is equal to 1, which is the horizontal asymptote. Is lastly, it intersects at 0, 2 on y-axis. Yep. Right. So let's just leave the fx sketch on the graph. Right. And let's draw the horizontal asymptote as well. So that's y is equal to 1. And it will approach to y is equal to 1. Oops. Yeah. Let me change the color. So it will infinitely approach to the pink one, which is our asymptote, but never across it or say touch it. Right. So that's all we got for this question. Let's leave a comment there. Okay.